Network security groups, NSGs, are fundamental components in Azure's virtual networking environment. They work at the subnet or network interface level, controlling the flow of inbound and outbound traffic based on defined security rules. By specifying source and destination IP addresses, ports, and protocols, administrators can enforce policies that reflect organizational requirements. This is particularly relevant after creating subnets, establishing peering connections, and defining routing tables, as it ensures that each segment of the network is appropriately protected. NSGs support a hierarchical approach, where rules can be applied both at the subnet level and directly on virtual machine network interfaces. Understanding these layers is crucial to evaluating how a single packet flows through different security checks. When multiple rules coexist across the infrastructure, comprehending the concept of an effective rule set is key to avoiding misconfigurations, ensuring authorized traffic is permitted, and denying traffic that may pose a security risk. Effective security rules represent the net outcome of all configured NSG rules that apply to a specific network interface or subnet. When various NSGs are associated with different layers, the rules do not merely combine, but ultimately form a consolidated policy. For instance, if a subnet-level NSG permits traffic on a specific port while a VM-level NSG denies it, the denial effectively takes precedence under the merge policy. This concept helps administrators understand actual traffic behavior instead of just individual rule sets. Analyzing effective rules is pivotal for identifying misalignments between the organizational security posture and implemented firewall logic. Through effective rules, Azure surfaces the final, enforced stance on inbound and outbound connections. This detailed realization assists in troubleshooting connectivity issues and ensuring compliance with best practices. By evaluating effective rules, administrators can detect hidden conflicts or redundancies that might otherwise go unnoticed, thus enhancing security administration. Azure NSGs apply rules based on explicit priorities, with lower numeric values indicating higher priority. An NSG first evaluates rules in ascending order of priority, from the lowest number, like 100, to the highest, such as 4096. As soon as a match is found, the packet's fate is decided, either to allow or deny traffic, and further rules are not evaluated. This sequential approach highlights the importance of carefully designing the priority structure. Often, administrators place the most critical deny or allow rules at lower numeric priorities to ensure those rules are processed first. Default rules have predetermined priority values, typically set at the extremes, e.g., deny all inbound at 65500, and custom rules reside in the middle to fine-tune security strategies. Understanding how priorities interlock within subnet-level and NIC-level NSGs is critical to confidently manage complex scenarios and avoid unintentional overrides of essential rules. Azure NSGs deploy with default security rules that provide baseline controls for common traffic types. For example, some default rules allow inbound traffic from virtual network addresses to ensure internal communication, while others explicitly deny inbound internet source traffic unless otherwise configured. Administrators can create custom rules to refine these policies, tailoring them to specific business needs. Custom rules define unique source addresses, protocols, and destination ports, enabling granular restrictions and permissions. When evaluating effective rules, the interplay between default and custom settings becomes apparent. Default rules serve as the fallback for traffic not covered by any custom rule, ensuring that essential Azure services remain accessible and hidden threats remain blocked. Meanwhile, custom rules can override these defaults when priorities are assigned. By balancing default and custom rules, administrators strike the right mix of security and functionality, reducing exposure to risk while maintaining the flexibility that evolving applications require. NSGs treat inbound and outbound traffic separately, each having its own set of rules. Inbound rules govern traffic from external or network sources destined for virtual machines or subnets, while outbound rules manage data flowing from these internal resources to external endpoints or services. Maintaining clarity between these flows is crucial, as different scenarios demand distinct policies. For example, administrators typically employ more restrictive inbound rules to block unwanted internet-based intrusions, while allowing certain inbound ports for application access, e.g., HTTP or HTTPS. Conversely, outbound rules often focus on restricting suspicious or non-essential egress connections to guard against data exfiltration. When evaluating effective rules, it is important to verify that each flow's configuration aligns with the overall security posture. Overlooking any outbound restrictions can lead to unintended communications to malicious endpoints. A holistic strategy ensures both inbound and outbound routes comply with organizational standards and regulatory obligations. Multiple tools are available to evaluate effective NSG rules in Azure, enabling administrators to verify configurations and troubleshoot issues efficiently. The Azure portal provides a direct and intuitive interface to list effective security rules on an NIC or subnet. Azure PowerShell offers script-based approaches to retrieve policy details, while Azure CLI caters to a similar need with cross-platform command line versatility. These solutions can be further integrated with automation pipelines, allowing real-time auditing or on-demand checks. For complex or large-scale environments, advanced logging and diagnostic data from Network Watcher can reveal patterns in how rules are processed. This data highlights areas needing refinement and is particularly useful whenever intermittent connectivity issues or unexpected denials arise. By selecting an appropriate tool set, graphical or command line, interactive or automated, professionals can simplify the evaluation of effective rules, maintain oversight of their network security posture, and keep continuous track of any changes. The Azure portal offers a graphical approach to examine a network interface's or subnet's effective NSG rules. Administrators can navigate to the VM or subnet resource blade and locate the Networking tab, which enumerates associated NSGs. By clicking Effective Security Rules, the portal aggregates both default and custom rules from relevant NSGs, presenting the final outcome. This interface shows rule priorities, sources, destinations, ports, and allowed or denied status in a consolidated view. Administrators can quickly spot conflicts, confirm if a particular port is open, or verify that denial rules are functioning correctly. Additionally, the portal simplifies the process of editing or adding new rules, allowing quick testing and validation. Such visual inspection proves invaluable when immediate feedback is needed, as the interface updates rapidly to reflect changes. Although less suitable for large-scale automation, the portal remains a user-friendly solution for day-to-day verification and troubleshooting of targeted assets. Azure PowerShell provides a script-oriented mechanism to manage NSGs, supporting streamlined workflows for large or dynamic environments. Administrators commonly employ cmdlets like Get as a Network Interface and Get as the Effective Network Security Group to query applied NSGs and retrieve effective rules. By parsing these outputs, teams can programmatically identify potential conflicts, enforce consistent naming conventions, or generate compliance reports. For example, PowerShell $nic equals Get as a Network Interface, name MyVMNIC, resource group name MyArt is Effective Network Security Group. Network interface $nic, this snippet collects the overall rule set for a specific network interface. PowerShell's inherent scripting capabilities allow administrators to integrate these commands into larger deployment scripts or configuration management processes. When combined with logging frameworks, PowerShell helps track changes over time, ensuring that newly created rules and modifications are immediately tested. Its repeatable, robust nature makes it an essential tool for advanced or automation-focused tasks. Similar in concept to PowerShell, Azure CLI commands offer cross-platform convenience for effective NSG evaluations. Administrators can retrieve a network interface's assigned NSGs and examine the net set of rules. A typical usage might involve bash AZ network nic show, name myVMNIC, resource group ARG AZ network, nic list effective NSG, name myVMNIC. Resource Group MyRG, the first command reveals the NIC's properties, including attached NSGs, while the second enumerates the effective rules. This command-driven workflow suits Linux or Mac OS environments, as well as containerized DevOps pipelines. Azure CLI further supports JSON output for custom parsing, simplifying integration with third-party tools and specialized analysis scripts. While slightly more manual than automated pipelines, these commands still enable high-level orchestration, especially when combined with continuous deployment strategies. By maintaining consistent processes across platforms, the Azure CLI fosters collaborative management of NSGs among diverse teams. Azure Network Watcher complements NSGs by offering deeper insight into traffic flow and security rule application. With flow logs, a feature within Network Watcher, administrators capture IP traffic data passing through NSGs. This reveals which rules permitted or denied specific flows, addressing the gap between theoretical configurations and actual traffic patterns. Network Watcher also facilitates connection troubleshooting tools that simulate or test specific inbound or outbound flows. Administrators can validate whether a rule denies or allows a given TCP or UDP port request. This is particularly useful when diagnosing intermittent connectivity issues or verifying inbound routes after reconfiguring a newly created custom rule. Saved logs can be archived or streamed to services like Azure Storage or Event Hubs for further analysis. These insights reinforce the concept of a well-monitored network, where changes to rules or unexpected traffic patterns prompt immediate investigations. Evaluating effective rules is crucial in situations ranging from simple web applications to complex multi-tier architectures. In a typical scenario, a front-end subnet requires inbound HTTP and HTTPS ports open, while a restrictive inbound policy on the back-end subnet ensures only traffic originating from the front end is allowed. If these subnets also host separate resources with different NC-level NSGs, the effective rules converge from both layers into a coherent policy. Another common use case involves restricting outbound connections to specific domains for compliance or cost management, especially if the organization wants to prevent unauthorized communications. In these instances, administrators combine default rules with multiple custom entries to narrow traffic flows effectively. By systematically examining the effective security rule set, teams can detect any oversights, such as failing to enable critical ports for application functionality or accidentally leaving open ports that could introduce vulnerabilities. To ensure optimal security and maintain operational efficiency, several best practices should be followed when creating and evaluating NSGs. One core principle is adopting a least privilege approach. Only open ports, protocols, and addresses truly required for application functionality should be allowed. Additionally, frequent reviews of effective rules can guarantee no stale or overlapping entries remain. Centralizing logs in a log analytics workspace and leveraging tools like Azure Policy to audit NSG configurations fosters consistency at scale. Another practice involves grouping VMs with similar workloads into application security groups, ASGs, to simplify rule management and speed up changes. Administrators should also separate testing and production environments with distinct NSGs, ensuring changes do not inadvertently impact critical resources. Complementing these efforts, regular penetration testing and vulnerability scans will highlight areas needing rule adjustments. These guidelines form a robust framework for ongoing NSG optimization as environments develop. As a network grows and more services shift into Azure, the complexity of security requirements tends to escalate. Forward-thinking plans might include automated policy enforcement using Azure Policy or third-party solutions, which systematically verify newly created resources against established NSG standards. Centralized logging and advanced analytics can further refine rule sets, identifying trends that point to emerging risks or potential misconfigurations. Organizations should consider adopting infrastructure as code, IAC, templates that embed NSG definitions, controlling rule creation and updates through version control pipelines. This approach ensures consistent deployments across environments. Teams can also explore advanced features like just-in-time VM access, which extends NSG policies to dynamically allow inbound connections. As more workloads incorporate microservices or container orchestration, NSG management might integrate with service mesh security frameworks. Adapting to these evolving solutions positions administrators to maintain robust security stances, leveraging NSGs as a core layer of Azure defense.